with f of a not equal to f of b, and let n be a number between f of a and f of b. All right, then there exists C in the open interval from a to b such that f of c is equal to n. So I think I'll probably spend the first about 10 minutes of next class showing you the proof of this. It is substantial and difficult in its entirety, but each step of the proof is understandable. And I think it's worth looking at the proof for about 10 minutes of our class time because it'll help you understand why that axiom 11 in the real numbers is so important. Remember the least upper bound property? Like to prove the intermediate value theorem, that idea that every set which is bounded above has a least upper bound, it is critical to the proof of this theorem. And it's basically what forbids there being a hole in the graph of a continuous function. So like this theorem is totally unsurprising. Like geometrically, it's like, well, duh. Like look at what this theorem says. If this is f of a, and this is f of b, right? And, so either the function, it starts here. I mean, I'm gonna assume that f of a is less than f of b, and I'm assuming that a is less than b is assumed here, right? And we're also assuming that a is not equal to b, obviously. But either the graph looks like this, or f of a is smaller than f of b. And where is n in this picture? Some value between f of a and f of b, right? So, like, you could visualize that by this horizontal line. What's this theorem say? It says that if the function's continuous, then of course, as you draw the graph without lifting your pen, you have to somewhere hit that, right? I'm justified in saying that because a to b is a connected domain. So this is the intermediate value theorem. Counterexample. And it's not really a counterexample to the theorem. It's just a place where it's not going to work. Like the property of the intermediate value theorem won't work. How about that function that we've been keep coming back to, x over the absolute value of x? Right? What's that look like? This guy, right? There's the graph. So I could look at, say, a equals -2, and b equals to 2, for example, right? Look at that closed interval for that function. Is f of a equal to f of b? No, they're not equal. -1 is not equal to 1, right? Pick any value you like between -1 and 1, right? Pick n equal to 0, pick n equal to whatever, n equal to 0.5, sure. There does not exist, right? Come on. There does not exist c in -2 to 2 such that f of c is equal to 0.5. This does not contradict the intermediate value theorem because, of course, This function f lacks a critical property, continuity. It's not continuous at 0 because, well, 0 is not even in the domain, so we certainly can't say it's continuous there. Right? Bless you. Oh, it's okay. You got the mask on. You're golden. You got the COVID? Uh-oh.
That's why I try to hold it.
I tell you what, it's the worst thing at like church now. Like our 3-year-old sneezes or something, and then like the old folk in front of you, like it's like it's nothing. It's just he's a 3-year-old. Like let him be. Actually, 0 is the most interesting intermediate value, right? You notice that this function changes from positive to negative without actually crossing 0. That's only possible here because this function is discontinuous. So let me show you an example. Suppose f of x is equal to 3x cubed minus 13x plus 22. Problem, show that f has a real 0. What does that mean, f has a real 0? Show that you can factor out, show that there exists c in the reals such that f of c equals to 0. Now, if all you have is algebra, you gotta hope you can factor the thing or find the number that when you plug it in, it's 0. But with the intermediate value theorem, we can go through a 3-step program. Here's our 3-step program. Program step number 1, f is continuous on the reals. Right? So definitely the intermediate value theorem applies. Step number 2. And this is where I need you guys' help. What number can I plug in here to make sure f is negative? I want it to be negative. I want f to be negative. Here, let me be rather abusive. Minus 1,000. Because I don't want to think about it. F of minus 1,000. What's that going to be equal to? 3 times minus 1,000 cubed minus 13 times, minus 1,000 plus 22. Let me point out that the last two terms are what? Stupidly small, right? That's a technical term. I'm just joking. That's not actually a technical term. I've not seen someone use stupid in a definition yet. Hey, I need to work that into the next thing I write. I could be the first, maybe. If you hear a mathematician use the phrase almost everywhere, that actually has a technical meaning. If you hear a mathematician use the term solvable, that has a technical meaning. Simple has a technical meaning. All kinds of words that are familiar to you from everyday life have technical meanings, but stupid, not so much. Anyway, my point is this is the winner, right? So it's like minus 3 billion. So this is clearly negative, right? Step number 3. Find a number where it's positive. I'll plug in 1. F of 1, I get 3 minus 13 plus 22, otherwise known as 12, right? I said this was a 3-step program. That's true. That's not entirely true. It's a 4-step program. Step number 4. N equals to 0 is an intermediate value of f of minus 1,000, which is less than 0, and f of 1, which is equal to 12, which is greater than 0. Thus, by intermediate value theorem, there exists C, right? In fact, C where? I mean, here's where my greed has not paid off. All I can say is that there's some C between minus 1,000 and 1, such that what? F of C, which is, by the way, equal to 3C cubed minus 13C plus 22 is equal to 0. So the intermediate value theorem doesn't tell you what makes the function 0, but it does say that, hey, that function's 0 somewhere. This is actually very useful, even from a calculational applied perspective. Can you tell me, I mean, so we showed that there exists a C, right? But we didn't actually find the C, we just know it's somewhere between minus 1,000 and 1. How could you do better to find the C? Like, what can you guys give me an idea? Like, what would you do if you were going to actually try to like find a better approximation for what C was? Pick the negative number smaller first. Yeah, try like minus 1 maybe. Yeah, I think that's the first thing I would do. I would try something much less ridiculous, like, I don't know, maybe minus 10 or something, right? Yeah, I would try minus 10. But once you find a reasonable smaller number, then what you can do is you can divide and conquer. You can like take the midpoint of your interval, check the value at the midpoint. If you see that the sign changes from plus to minus on one side of the interval, then you know that wherever there's a sign change from plus to minus, the 0 must be somewhere between those sign changes, right? And you can just keep like dividing your interval smaller and smaller, looking for where the sign flips. And so this gives us an algorithm for root finding called, I think it's the method of division or something, but I described this algorithm in the notes in more detail. Maybe we'll try that out on an example next time. But anyway, I hope that gets us started. Continuous functions, nothing to be scared of. Intermediate value theorem, you just got to know what it's for, right? It's for showing the existence of something. It doesn't actually find the number for you. Anyway, thanks, guys. I will see you Wednesday.